Good evening, everyone. So, um, last week we talked about extrude surface and revolve surface on surface modeling. But this week we'll be talking about surface sweep features. And I would not want to go further by modeling without really explaining what surface sweep features is. So, I would like to outline the possible advantages of surface features, the properties of surface features, the outlines in surface features, and also the disadvantages of surface features. So before I start, I'll start by defining what surface features is really all about. Now, surface features allows you to create complex 3D geometry by sweeping one or more sketch profile along a specified path. This path is defined by one or more sketch curves or edges. Surface sweep features is used for creating organic or intricate shapes such as handle, grooves, or other intricate surface details by controlling the orientation and shape of the sweep. In industrial design, product modeling, and other applications where precise control over surface geometry is required. I think you understand that. Now, there are some features in, or should I say properties in surface sweep features that you need to know before going into modeling. And these properties include, we have what we call the sketch profile. Now, what is a sketch profile? A sketch profile is the 2D shape or outline that you create in a sketch plane. Any 2D shape or outline that you create in a sketch plane is called a sketch profile. You've done sketch profile in extrude surface, you've done it in revolve surface, so it's not a new thing. Now, it defines the cross-section of sweep features that will be extruded along a specific path to create a 3D shape. It's essentially the shape you want to replicate along the sweep path to generate the desired geometry. Sketch profile can be a simple closed contour or a more complex shape depending on your design requirement. So it differs. A circular profile is a sketch profile that is defined by a circular shape. So unlike your sketch profile that the shape varies depending on your design requirement. For a circular profile, the shape is circular. So this entails that along a 3D shape, when using circular profile, the resulting sweep feature will have a circular cross-section along its entire length, providing uniformity in shape throughout the sweep path. Hence, useful on creating cylindrical or rounded feature in your SolidWorks model. Let me specifically tell you what a profile is and what a path is, because when we'll be modeling, you'll be seeing us, we'll be applying profile and path. So now, a profile is any cross-sectional shape that is used to sweep along a path to create a surface. This profile can be a closed, open sketch entity. A closed or open sketch entity, such as a line, an arc, a spline, or any combination of these. This profile defines the shape of the resulting surface. So path refers to the trajectory or the route along which the profile is swept to create the surface. The path can be a sketch entity such as a line, an arc, a spline, or a combination of these which guide the movement of the profile. It determines the shape and direction of your resulting swept surface. Now, we've talked on profile and path. We'll be talking about our guide curve. Our guide curve, this is an additional curve used to control the shape of the swept surface. an additional curve used to control the shape of the swept surface. Unlike the path which defines the overall trajectory of the swept, the guide curve influences the shape and behavior of the profile as it moves along its path. Guide curve can be used to create complex surface geometry by defining how the profile deform or twist as it follows the path. Now we've talked on guide curve. We'll be talking about the start and the end tangency. What's a start and end tangency? You see all these things I'm talking about in SolidWorks. I just want to first of all let you understand what they are before we start using them. So I will not have to be explaining while modeling. Ensures the profile maintains tangency with the path at the beginning of sweep. So when you want to create a tangency with your profile at the beginning of sketch, you use your start tangency. That is, the profile smoothly defines transition into the sweep at the starting point without any abrupt changes on curvatures and on curvatures. Same also applies to end tangency. It ensures the profile maintain tangency with the path at the end of sweep. That is, it provides smooth transition into the sweep at the ending point without any abrupt changes in curvatures. So that's just what it means. But you will be seeing curvature display on SolidWorks there. What is curvature display? Curvature display is usually used for visualization of surface curvatures. So when you want to display surface curvature, you click on your curvature display. But why do you want to display surface curvature? Visualization of the surface curvature, that is, display color gradient on the surface to represent changes in curvature. You display color gradient on surface to represent changes in curvature. Now, visualization enables designers and engineers to evaluate the smoothness and continuity of surfaces, which is crucial for achieving high quality design in areas like aerodynamics or aesthetics. Now, curvature display allows user to identify areas of high or low curvature, ensuring that the surface meets design requirements and aesthetics preferences. Now we've talked on most of the properties in sweep surface. Now I'll be outlining the disadvantages of sweep surface. Now when it comes to the disadvantages of sweep surface, we have what we call complexity limitation. No, as you continue to as you begin to use sweep surface, you discover that you may struggle with creating complex geometry, limited control over twist. While the guide curve can be used to control the shape of sweep profile, achieving precise control over twist can be challenging. You get? So number 3, we have surface continuity. When it comes to surface continuity, achieving smooth surface continually, especially between multiple sweep feature or adjacent sweep, can sometimes be difficult. Number 4, we have performance consideration. Complex sweep can affect model performance in terms of computation, resources, and regeneration time. You understand? So it affects model performance in those terms. Now the fifth one, which is the last, is what we call the limitations with intersecting geometry. There is limitations when it comes to intersecting geometry. So what we'll be doing now is to start modeling, and I'll be showing you how to apply sweep surface. Thank you very much. Okay, so we'll be continuing with modeling on SolidWorks. So like you can see, I've already opened my SolidWorks. So let's click on new file, Control N, new, then path. So we can start applying examples of sweep surface. So now, like I told you, before you use sweep surface, you must actually have defined your profile and your path. Your profile and your path, and I've made mention of what a path and a profile is. I told you that the profile is the one that defines the section of what you are modeling, while the path is the one that shows the direction of the profile. So now let me start by doing something very simple. So I defined my profile. So I'm using a hexagon, a polygon with 6 sides. That's 1, 2, 3, 4, 5, 6. So what do we even call it? They call it I think we call it is it octagon is 8, that's 6 is hexagon. So we've done a hexagon, then I exit this sketch. I want to create another profile adjacent. This profile should be telling me the direction, the path, the direction of my. So let me just create something like this. Okay, now, so now if I go to my sweep, this is my sweep now. Sweep, we now have what we call the sketch profile. You can see your sketch profile. So your sketch profile, I've already defined what the sketch profile is, so I will not be going back. So this is now your sketch. You click on your sketch. Sorry, so now this is asking for a profile. So you click this is your profile, and this is asking for your path. So you click this. So did you see that it extruded this profile along this path? So that's what sketch profile is all about. Now, we talked about guide curve. Guide curve, the ones that guide the boundaries of your extrude. You understand? So there is also option for follow path, profile orientation, you say follow path, profile twist, tangent to adjacent faces. If you want your profile twist value, if you want it to twist, you have to give it a twist value and it will twist. You understand? Are you seeing what's going on there? So if you want your profile to twist, just give it a twist angle. If you want to use angle, that's for twist. If you want a specific direction vector, then you would have to give it that vector direction, which we did not do here. So tangent to faces, if there's any face, then you have to tangent it to that face. So I think we'll go to none for now. Now there's what we call the start and end tangency, which I can just put follow path tangent. So it will be tangent to this profile, to this path, sorry. So if you want to display your curvatures, so to display curvature, you want a zebra preview. If I don't want this zebra stripe that is showing, I can just eliminate it. I will not be seeing those zebra. If I want a mesh, if I want to see a mesh, I can increase the number of mesh I want, and it will show me the mesh. You understand? If I don't want this mesh, I click back. We have what we call this, the curvature comb. So if you click for curvature comb, you see them. But I don't even want all this on zebra stripe. So I think that's all for now. Let me leave the zebra stripe. So did you get it? Now imagine I want to define my boundary. So now Now that I have a a sweep, a path, a profile and a path, I can as well create a guide curve. Now to create a guide curve, I come to the right, the top plane, and I create another sketch to show how I want this thing to be guided. So now I'll be using my spline. So using my spline, I create something that looks like this. Okay, let's just leave it like this. Something that looks like this. I can just use this like an S to just show how it's gonna be. It's looking like an S. Okay. So, okay, let's just leave it like this. So this is now my guide curve. So now let's go back to our sweep. Pardon me, I would love to increase this downward a bit. So when we go to our sweep surface, we click on our profile, we click on this, and now when it comes to guide curve, look at what I'll do. I'll click on this. Now you'll be asking, why is it not showing? Why is it not working? Why is it not working? Let's go back and try to troubleshoot. Why is it not working? So let me click this and click this surface and say tangent. So go back to this and then sweep, click my profile, this, and my guide curve, this. So can you see it now? It's working. Why was this working and that one not working? If you notice, when we are creating this, we created it to be more than to intersect with our guide curve. So, and I told you one of the disadvantages of sweep cut is intersecting geometry. So when it comes to tangency, we can say path follow path. We remove merge smooth surface. We'll not be seeing that. So you can see now, you can see your what are they calling it? You can see your mesh preview. If you go to your zebra comb, they are now displaying this red line. Is just trying to give you. So like I said, engineers or designers can use this to study the surface and for either for aesthetics or just for aesthetics, to make sure that you are having a so like you can see, so that's just it for this. So let's create another example. Another example, we want to create this. We create a cycle and we want this cycle to be bent by the side. So we'll come to the right plane, create, let's use a spline to show that it is bent. So we can bend it ourselves here just to make this horizontal. So we've created this bent.
we want to also bend it by the been able to bend it by the let's bend it by the top also. So we've been able to bend this by this side. We want to bend it by the other side. So why not I go here? Let's create a line. So this line will serve, use it to create a plane. So I think we have a plane here now. So I want this by the top to be straight. Let it not be bent. Are you getting what I'm doing? So now look at it. So when I go back to my sweep surface, I click on, for my profile I click on this. For my path, click on this. So watch what is going to happen. So that's what is going to be happening. Come on.